Hello again, friends. Welcome to my home. This is me going over the first test on derivatives I ever gave you, and this is the second page. All right, second page starts with a pretty straightforward problem. It is just find the derivative of this expression in terms of x. Since it's separated by pluses and minuses, we can just take it term by term and use the power rule. So derivative x to the fourth is 4x to the third. The derivative of 3x squared is 3 times 2, which is 6, and then x. And then the derivative of 7x is just 7, so we will be minusing 7, subtracting 7. But yeah, pretty straightforward. Not a whole lot to say there. Just remember the power rule and you won't have much trouble. Okay, this one, because it was hand-drawn, I don't have this in the electronic copy, but you need to find constants a and b so that the equation y equals ax minus a matches x over x plus b matches the graph. Now the graph is always going to look something like this. When x is, it always is going to have to go through this point. And they're going to be horizontal, so they're going to be horizontal asymptotes and vertical asymptotes, really one of each. So let's make one up right now, right? Let's put one with a vertical asymptote here, and horizontal asymptote, this one was negative, so give it a positive horizontal asymptote, like that. Let's put that at 1, 2, 3. So this is marked off at x equals -2. This is marked off at y equals 3. These markings will always be provided so that there's no question of interpretation when you're reading a graph. And so to fill this in, it would have to look something like that. So here's the graph of the equation with the asymptotes. Really, you don't need the graph so much as you need the asymptotes. And basically, the vertical asymptote is the x value when the denominator equals 0. So we know that -2 plus b equals 0, which of course means that b is 2. Looking over here, the horizontal asymptote is the limit, written in limit form. It's the limit as x increases without bound, kind of in either direction of this. Well, if you look at it from a limit perspective, this minus a and this plus b kind of don't really matter. They matter a little bit, but you can make them to matter as little as you want. So we choose to have them not matter at all. So that means our horizontal asymptote, whatever it is just a. So that means that in our case, a equals 3. Both of these you should be able to read off the graph with little effort. Now, if f of x equals x plus secant of x, then f prime of x. So again, a pretty straightforward problem. It is just asking you to find the derivative of this function. F prime of x, since we're separated by plus, it's term by term. Derivative of x is 1. The derivative of secant is secant x tangent x. I know some of you remember it as tangent x secant x. Doesn't matter either way. As long as they are both written and they are multiplied together, that is exactly what I want. Great. Moving on. If f of x equals 5, then f prime at 4 is equal to what? This is, I hate to say this, but this is a little bit of a trick because the derivative of a constant function is 0. So f prime at any x is just 0. So certainly, when x is 4, this is equal to 0. on. Now, I did my best to signpost what you need to do here by making this part italics and bold. And I want to say that these problems are all taken from actual AP tests that have been administered, and I'm pretty sure that is how it was in the actual AP test. They really want, I really wanted you to see that I was asking for a minimum value, but I was not asking for the minimum value of this. I was asking for the minimum value of the derivative of this. So the first step is, of course, finding what the derivative of this is. Well, it's going to be 3x squared minus 6x plus 2. Okay. Now, this is a quadratic equation. So once again, I've given you two options by having this problem. There is the option of, wait a minute, the minimum value of a quadratic equation happens at the vertex. And I can find the vertex because I know the x of the vertex is equal to negative b over 2a, which is just 6 over 6, which is 1. And then if we go, since we're asking for a minimum value, I have to take this one and plug it in here. So 3 times 1 squared minus 6 times 1 plus 2 becomes negative 1. Okay? So that is the no calculus beyond the first method to find the, notice it's not finding, we still have to plug back into the actual expression to find the value, but we didn't use calculus to find the x value. But there is a method to use calculus, and that is to take the derivative further, the second derivative, which gets us to 6x minus 6, and then because minima and maxima happen at critical points, we find a critical point. So we set that equal to 0, we get 6x equals 6, x equals 1. Okay. So at this point, since there is only one critical value of this expression, you can either take it on faith that I gave you one that has a minimum value, or you could go check to see, you could use second derivative test or anything you want to see that, oh yes, this derivative of this expression goes from negative to positive, so this is indeed a minimum. And then you'd still need to take our x equals 1, plug it at there, and you'd again get the expression, the answer of negative 1. So you can either use the technique of taking the derivative twice, or you could take it once and then use what you know about quadratic equations. Either way is fine. I'd say they're about equal amount of work. All right, last one on this page. If y equals 3dx, then what is the definition of dy dx? And again, I italicized this for a reason. Some of you tried to use the rules you know to take the derivative of 3 to the x, and here's the thing. The power rule does not work. If the x is in the exponent, this is an exponential function. It behaves fundamentally differently than our polynomial functions that we use the power rule on. So remember, power rule is when our variable is the base, not the exponent. We do not have, at this stage in calculus, we still do not have the tools to address this and actually find what the derivative is. But I didn't ask you that. I asked you what the definition of the derivative of it is. And if you remember from the first video, or just you should remember this, the definition of the derivative is a limit expression. I'm going to use delta x for this, just as the first one. The limit as some change in x goes to 0 of So the definition of the derivative is this limit of what's called the difference quotient. And in this case, we can just sub in our particular f. So our f is 3 to the x, so the definition of this is going to be the limit as this goes to 0. And you could use h instead of delta x. I'm not care about that. So 3 to the x plus delta x minus 3 to the x over delta x. Just the expression. That's all I wanted was this expression. Nothing more, nothing less. And you need to be able to recognize this expression or something like it. So you could have the mathematically identical limit as h goes to 0 of 3 to the x plus h minus 3 to the x all over h. That's fine. I'm happy there. But you need to be able to recognize that form. And that is all I have to say about that page. See you on the next page.